Sound the trumpets. This is lesson 26, your final lesson in Math for Teachers 2. Take time as always to review your goals, finding that math vocabulary, making sure that you're understanding those goals and the definitions by the conclusion of the lesson. Hit pause and take time to read these goals. There's two key terms for this final lesson. One is ratio comparison problem, a problem in which all four values related to two ratios have been given, and the goal is to compare the ratios. So the question here are these ratios equivalent? $27 for every 3 people. $54 for every 6 people. Are these ratios equivalent? Yes or no? Think about your mental math. 3 goes into 6 2 times. 27 goes into 54 2 times. So yes, these are equivalent. Next key term, find the missing value. Missing value problem is a problem where 3 values related multiplicatively are given and a 4th value is missing. Find the value of x when x 5 equals 4, 10. So again, doing that mental math, 5 goes into 10 twice. So 2 goes into 4 twice. Okay. Well, we're going to continue to work on it. Okay. Finding the missing value of x. All right, how to prepare and what will you learn? Right? So now you're getting more and more proficient and comfortable using the different strategies: unit rate, within unit scale factor, cross unit scale factor, scaling up, scaling down, and cross multiplication. Right? You heard my tone of voice change. It never hurts to use different voices, different intonation, different volume even. And we're using these different strategies to solve missing value problems. Okay, so again, there are resources, right? Scaling up and down. And the last one here is some free websites. So let's review illustrative mathematics, and we'll move to that. So this is a different website. It's called Illustrative Mathematics. And this site, again, as typical, gives you the grade level, the domain, and then it starts to tell you about the cluster and even the standard. Okay, so the task here is reasoning about multiplication. It gives you a task, gives you a word problem, and it works through the word problem. So your classmate Ellen says, when you multiply by a number, you will always get a bigger answer. Look, I can show you. Start with 9, multiply by 5, the answer is 45, and 45 is bigger than 9. It even works with fractions, she tells you. Start with 1/2, multiply by 4, the answer is 2, and 2 is bigger than 1/2. Ellen's calculations are correct, but her rule does not always work. For what numbers will Ellen's rule work? And for what numbers will Ellen's rule not work? Okay? And this website walks you through those answers, right? So thinking about the commentary of it all, as well as the solution. This is a website that may even help you gather the language to support your children. Okay. And again, when it says C7 and 6.2, that's Common Core State Standard. Okay. So you'll start to learn those language. Common Core State Standard for English and for math is going to become really important in developing your language aligned with the curriculum that's typically provided for you. Okay, so we're continuing with proportional problems. The story problem here is a box of strawberry flavored candy weighing 12 ounces cost $3.60. A box of gummy bears weighing 16 ounces cost $5. Which candy is a better buy? Okay, my suggestion here is you say a better value, right? Because you're looking at the cost per ounce. So you're going to work for the next several minutes, go into your workbook again. This is the third lesson. You should be good to go with this patterning. For reference, the first child is Dawn. So you want to hit pause. Think about this story problem. Are you going to rewrite it? How are you going to rewrite it? Are you going to write one sentence and then 2 sentences and then 3 sentences? Right? Reading it out loud, writing it down, go into your workbook, start with Dawn, and then come back. Hit pause now. Okay, welcome back. How did Dawn solve the problem? Is her strategy mathematically valid or not? Valid, correct, invalid, incorrect. Okay. Thinking about the language you're going to use and best practices to use the language consistently. Okay. So Dawn wrote the equation that the $3.60 divided by 12 equals 30 cents per ounce. And $5 divided by 16 is 31 and a little more cents per ounce. So 31.25 per ounce. Strawberry filled candy is a better buy, and this is correct use of the unit rate strategy, right? So in your workbook pages, could you explain that it was correct unit rate strategy? Okay. And again, you can go back to a previous lesson if you want a refresher of the core of that strategy. Chrissy decided to do equations of 360, so she moved the decimal point, equals 30 times 12. Right, so she moved the decimal point on $3.60. And then she said, okay, I've got 12 ounces. So 12 times what equals 360 to find 30? And then she wrote 30 times 16 is 480. 30 times 16 equals 480. So in that case, she was looking at 16 ounces of the gummy bears. If she times that by 30, she got 480. But the gummy bears cost more than 480 cents. So they are not the best buy. Okay. I want you to think about how she wrote her equations, right? One started with the total, the second one ended with the total, and giving allowance that this is her math. From her mental math to the paper, this is Chrissy's logic, right? On the board, you might have written the summations differently. What is different about this type of proportional problem compared to the ones that we've already discussed recently? So in this problem, 4 quantities are given instead of just 3, with 1 missing. Proportional problems. And the quantities are related to 2 ratios. So we need to compare the 2 ratios and then determine which is greater. right? So again, in this story problem, we're saying which candy is a better buy or a better value. Okay. The problem above is called a ratio comparison problem, whereas the problems we discussed before are called missing value proportion problems. Missing value proportion problems, remember, have that X factor. When we solve missing value problems, we found the missing value by assuming that the two ratios were equal. In other words, we assume the values are in proportion to each other. In ratio comparison problems, for the most part, the ratios will not be equal. So we have to figure out how to interpret differences between the two given ratios. For example, what it means in context of each problem when one scale factor or unit rate is greater than the other. Okay, so you're given all four, but they're different in their ratio factor. Okay, let's do a few more together. Jackie is 70 inches tall and can jump 200 centimeters. Joyner is 72 inches tall and can jump 210 centimeters. Proportionately speaking, who is the better jumper? Okay. So you see, he wrote the equation 70 over 200, 70 inches tall over 200 centimeters that he can jump, or she can jump, equals 72 over x. So 70x equals 14,400. And then x becomes 205.7. So Jackie can jump better, is the better jumper, excuse me. Okay. Is this correct? This is an incorrect multiplication strategy. Incorrect. So take a few minutes and think about how you would explain to this student why it's incorrect and how to resolve the problem. Let's move on to Christine. Is her strategy mathematically valid or not? Same word problem. Jackie is 70 inches tall, can jump 200 centimeters. So Jackie can jump 200 over 70. 2.857 centimeters per inch of height. Joyner can jump 210 over 72. 2.916 centimeters per inch of height. So Joyner is the better jumper. This is a correct use of unit rate strategies. There are two more slides that I'm going to suggest. Actually, I'm sorry. There are 4 more slides that I'm going to suggest that you review to reinforce this concept. Take time to review. Go back and repeat some of the slides. The slides are posted in conjunction with the video in each of the lesson submodules.